Hi, well, welcome to Chapter 2, Section 3, Part 2. Now that you know about writing matrices, we need to learn how to use matrices to solve systems of equations, no matter how many variables, and how to interpret their solution. So, for example, in example 1, this is what a solution looks like. After you put it into the calculator and it does it for you, and I'm going to show you how to do that, this is what it looks like. Now, what this means is that since you now know how to put an equation into a matrix, you know that this first column is x, this is y, this is z, and it equals something. So if I were to rewrite this back in the original form, we would have 1x plus 0y plus 0z equals negative 1.4. We would also have that 0x plus 1y plus 0z equals 5.2. And then in the last row, we would have that 0x, 0y, 1z equals 16, which means that if I were to write that in an ordered triple, we would have negative 1.4, 5.2, 16. So that's how you read an answer. Now, these are general steps. For solving using technology. First, you write an augmented matrix. Then you enter the matrix into your calculator. You use the reduced row echelon form to rewrite the system. And then you interpret the result, just like we just did, to solve it. So let's do this. So first, with example 2, we need to put it into an augmented matrix. So if I were to rewrite this as a matrix, you should know already, we would get 2, 3, negative 1, our line 15, 3, negative 9, 9, negative 12, 4, negative 3, negative 1, 19. So that's the matrix we're putting into our calculator. So let me show you how to do that. When you put it into your calculator, you're always going to go to a new document and add a calculator page. Now we're going to do the reduced row echelon form, and you actually have to put that into this calculator first. So we're going to go to Menu, Matrix and Vector, Reduced Row Echelon Form. Now it has to be reduced. If you just do row echelon form, it's actually only doing one step when you want it to do all of the steps for you so you don't have to worry about it. When you do that, it gives you RREF and then parentheses. If you remember that, you can actually type it in. Then we're going to actually put in a matrix. Now you remember where we went to find the absolute value function? In the button next to the book. Okay, so it's highlighted in red on my paper, or on the screen. And right in the middle is that 3 by 3. That's how you put a matrix into your calculator. Now for this, we actually had 3 rows and 4 columns, so I'm going to go down here and then click on the 4 and hit OK. Now I'm going to put the numbers in exactly the way that I wrote them. So 2, 3, negative 1, 15, 3, negative 9, 9, negative 12, 4, negative 3, negative 1, 19. Now you can't put the line in, and that's okay. We're not worried about the line. It's still going to work out the way we want it to. You hit enter, and there you go. Our answer is 5, 1, negative 2. Because remember, the first one is x, the second one is y, and the third one is z. So if I were to go write that on my paper, my solution would be 5, 1, negative 2. Alright, so let's do a couple of more examples. These other examples are going to deal with the all real numbers and no solution option. Because as you know from solving systems, you can get those as answers. So, let's look at examples 3 and 4. So go ahead and write them down, pause, and write them down, and then I'm going to go ahead and put them into my calculator. So let's go put it into our calculator. We're still going to do RREF, reduced row echelon form. I'll show you how to find that again. Menu, Matrix and Vector, reduced row echelon form, not row echelon form. And then we put in our matrix. We're going to press the button next to the book, the 3 by 3, This is still a 3 by 4, and I'm going to put my numbers in. We get 3, negative 1, 2, 4, 6, negative 2, 4, negative 8, 2, negative 1, 3, 10. So for now, I just want you to write this on your paper. After your example, go ahead and put that as the solution, and we'll come back to what it is. Okay, for now, we're just going to go ahead and do the next one. And like I said, if you type in REF, it'll straighten out. You put your parentheses. We still have a 3 by 4. And now I'm going to put the equation in from example 4. We had 1, 3, negative 1, 2, 1, 1, 1, negative 1, 0, 3, 2, negative 3, negative 1. We hit enter, and there's the solution for this one. So make sure you have both of those written down in your notes. Pause if you need to. And we're going to go back. So here's examples 3 and 4. Now the matrices that we got were 1, 0, negative 1, 0, 1, negative 5, 0, 0, 0, 0, 0, 1. And that looks different from what we got in example 2 and example 1. And the reason is because now they're telling us that 1x plus 1z, minus 1z. So this is what's happening. X minus z equals 0. That's that first line. They're telling us that y minus 5z equals 0. And don't forget, this is x, y, and z. And then they're telling us that 0 equals 1. Okay. Well, does 0 actually equal 1? No. It does not equal 1. So because of this row down here not being true, so that's false, therefore this is no solution. And that's it. You don't have to do anything else. Okay? In example 4, they gave us this, so let me write it down. 1, 0, negative 1, 0, 1, 0, 0, 0, 0, negative 1, 1, 0. Now this is a little bit different. This is very similar. It's true. We have x minus y. I'm sorry, that's not y. Y is the second position. This is the third. So x minus z equals negative 1. Y equals 1. And 0 equals 0. Okay, because there's 0 letters and 0 the number. Does 0 equal 0? Well, fortunately, yes, it does. Because this is true, and it's true no matter what your x, y, and z values are, this line is telling us that the answer is all real numbers. So, if you get your reduced row echelon form to look like the example 2, and here I'll show you this one more time, just so we're looking at all of them on the same screen. 1, 0, 0, 0, 1, 0, 0, 0, 1. This means that the answer is 5, 1, 2. Alright, so this one works because 1x here, 1y here, and 1z is here. Alright, it has to be that angle, that diagonal. They have to be ones and just ones. If you see something that isn't just ones, so for instance, right here, we had 1, 1, and then 0. Well, that means that there's something strange going on here, and it's not just going to be a normal number solution. Then you look at the bottom row. If the bottom row is true, then it's all real numbers, and if it's false, it's no solution. Here, it told us that 0 was 1, which is not true, so it's no solution. And then at the bottom, down here, it told us that 0 equals 0, which means that it is true. And that's it. That's how we're going to solve using technology. Have a great day.